Hello, my friend. Welcome to my channel. So today I am going to discuss a problem. This one is related to testing the difference between two means of independent samples. Here I am going to use t-test. This is the problem. The average site of a farm in Indiana County is 191 acres and a farm in Greene County is 199 acres. Assume the data were obtained from two samples with standard deviation of 38 and 12 acres respectively, and sample sizes of 8 and 10 respectively. Can it be concluded at alpha equals 0.05 that the average size of the farms in the two counties is different? Assume populations are normally distributed. So let's look at all the information here. So the populations are normally distributed. And as you can see here, the sample sizes are very small and there are no any information about the population standard deviations, right? That's why we are going to use t-test. Here we know sample standard deviation, so that's the only option we have here. So let's look at the alternative and the null hypothesis. So the null hypothesis, here we are talking about difference between two means, right? So I'm going to take first population mean as mu1 and the second population as mu2. So the null hypothesis should be equal and the alternative hypothesis should be, since we are looking at the difference, so it is not equal. So this is our claim in this problem. And let's look at the information. X1 bar. The first sample mean is 191. And X2 bar, the second population is the farms in Greene County and the sample mean is 199 acres. And then samples are from two populations, so with standard deviation. So here S1 equals 38 and S2, the second sample standard deviation equals 12. And then sample size N1 equals 8 and N2 equals 10. So these are the information. Alpha equals 0.05. So let's look at the test statistic here. Test statistics. Since we are using t-test, we use t-scores. So t naught equals, this is the formula, x1 bar minus x2 bar minus mu1 minus mu2 divide by s1 square over n1 plus s2 square over n2 whole square. So x1 is 191 minus 199 is x2 bar minus mu1 minus mu2. As you can see, mu1 equals mu2, then mu1 minus mu2 equals 0. Divide by s1 is 38 over n1 is 8. Here 38 square plus s2 is 12 and square divide by 10. And then take the square root. This value is negative number, negative 0.57. So this is the test statistic value. This kind of problems, we can use two methods to make a decision. One method is critical value method, the other one is p-value method. So let's look at the critical value method. So alpha is 0.05. As you can see, the null hypothesis is not equal. That means two-tailed test. So alpha is 0.05, but we have two tails in this problem. So this is t distribution. two tails here. This tail will be, the area is 0.025 because alpha over 2 is 0.025. This tail area is 0.025. So you need two critical values. One is negative critical value and the other one is positive critical value. Since we are in the t distribution, to use the t table, we need to find the degrees of freedom in this case. So the degrees of freedom here, since the variance are not equal, right? We have two different variance, the two different standard deviation. That means two different variances, right? So variances are unequal. So in this case, we use degrees of freedom as the smallest degrees of freedom. So here we have two degrees of freedom. Degrees of freedom 1 is 8 minus 1, which is 7. Degrees of freedom 2 is 10 minus 1, which is 9. So since the variances are unequal, so we use the smallest degrees of freedom, which is degrees of freedom. 1 is the degrees of freedom in this case, which is 7. So 7 is the degrees of freedom. And so you are looking at 7 in the t table. And as you can see, one tail, 0.025. So then you will see a number in the table, which is 2.365. So in the t table, these are positive numbers. So then this positive value is 2.365. Then this value is negative 2.365. So now you have two cutoff values, which are critical values here. So this is non-critical region, right? So this area is non-critical region. And now let's look at the p-value method. P-value. P-value is just the probability your t less than the absolute value of t naught, right? So here, the test statistic value is negative 0.57. Since the t table has positive values, so we are going to use the positive value of this number. So you are going to find, so this is the degrees of freedom. So under 7, you are going to find two values. Two numbers between 0.057, right? It should be 0. So 0.57 is between 0.00 and 0.711. So these are the two numbers from the t table. And then you look at the alpha values under two-tailed. Under two-tailed, you will see the numbers are 1.00 and 0.50. So here we can have a range for the p-value. P-value between 1 and 0.5. If you use a calculator, then you can get the exact p-value for this problem. But here, since we use the t table, we can have a range for the p-value. So let's make the decision here. We compare the statistic value with these two critical values. As you can see, negative 0.57 is between these two numbers. So that means this number falls in the non-critical region, right? So we fail to reject H naught. So we fail to reject the null hypothesis. And according to the p-value test, p-value, as you can see, the p-value is larger than 0.5, right? So that means your p-value greater than 0.05. So p-value is between 0.5 and 1. But your alpha value is 0.05. So since p-value is larger than 0.05, we fail to reject the null, right? Null is H naught. So let's write down the conclusion. Since we fail to reject the null, there is not enough evidence to support the claim that the claim is the average size of farm is different. So there is not enough evidence to support the claim, right? Because we fail to reject the null hypothesis. So that means the average sizes of two farms are equal in this case, right? Because we don't have enough evidence to support the claim that the average sizes of farms is different. So this is how you find the answer for this problem. So I hope you understand this one. If you have any questions or concerns, please comment. And thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.